Hola, and good day there, mateys. We have one more pathway to add onto our mole maps today as we start talking about molar volume. Now, as we've been talking about all these moles, we've talked about moles to molecules, we've talked about moles to grams, but you might be thinking to yourself, how do we measure gases in grams? We have solids and liquids that we can put on a scale pretty easily, but those gases get a little hard. So this is where molar volume comes in, or the volume of 1 mole of gas at STP. That's important. So mole to volume relationships are important because we can't weigh gases. Sad face. We can't just put a gas on top of the balance because they're lighter than air. They start to float away. They're not going to be weighed unless we put them in something. And we can't always capture the gases that we make. So that means that we have to use volume to measure moles of a gas. We usually measure gases in cubic centimeters or cubic meters. Okay, when you put gas into when you put the air into your tires, you don't measure it in grams. But we have a problem because gases change at different pressures and temperatures. So we can only be certain of mole measurements at something called STP. At STP, standard temperature and pressure. If you think about your car tires, you can kind of visualize or think about what actually happens with different temperatures. You know, when it gets cold and your tires go way flat, or in the summer, the tire pressure usually increases because of the warm temperatures. Okay, so that's why only at STP will work for this. We define STP, or standard temperature and pressure, of 0 degrees Celsius and a pressure of 101.3 kilopascals, or 1 atm. So this is kilopascals, it's just a unit of measure, and this means atmospheres. So 1 atmosphere is at sea level, 1 atmosphere sitting on top of you. The pressure equal to that. You have a lot of air sitting on top of you at sea level, about 18 pounds worth, so you may not realize it because we're used to it, but there is some pressure. And so at that 1 atmosphere is considered standard pressure. And at STP, 1 mole of any gas, no matter what it is, whether it's CO2 or O2 or N2, any of those gases occupies 22.4 liters. So our conversion factor here is 1 mole is equal to 22.4 liters at STP. So, mole map. We will add this pathway onto our mole map, but as we go through some of these examples, you can kind of think about where we're at. So we have now added a volume section. We talked about going moles to molecules, or moles to atoms, using 1 mole is equal to 6.02 times 10 to the 23rd. We've talked about going moles to grams, or moles to mass, using our 1 mole is equal to molar mass from the periodic table. And now we can add moles to volume at STP. Important. We will figure out how to go from moles to volume, not at STP another time. But right now, we're only looking at that standard temperature and pressure. So 1 mole is equal to 22.4 liters at STP. So again, when you're using your mole map, all you have to do is figure out where you're starting. So say I'm given grams and I have to find volume, and that's the pathway I take to get there. I would go grams to moles using my molar mass, and then I would go moles to volume using my 1 mole is equal to 22.4. Figure out where you're at and then use the steps to get there. So let's try an example here. Mole to volume relationship with sulfur dioxide. It's a gas that we get by burning coal. It goes into the air and it actually makes acid rain. But if we wanted to determine the volume in liters of 0.6 moles of SO2 at STP. So we are starting with what we know here, 0.6 moles. So that puts us in the mole block right here, and we are trying to find the volume. So we have to go from moles to volume. So on bottom, we are going to put moles. We can see from our mole map that it's just going to be 1 step, so we can go directly moles to liters, and we know that for every 1 mole, there are 22.4 liters. Our moles will cancel out. Multiply across the top, divide across the bottom, and you should get an answer of around 13.4 liters. Not too bad. Let's try another. This one, we are being asked for what is the volume of 3.2 times 10 to the 23rd molecules of CO2 at STP. It's important. So this time, we are starting at molecules, and we have to get to volume. So this one's going to be two steps. We have to go molecules to moles, moles to volume. So from molecules to moles, we use 1 is equal to 6.02. From moles to volume, we're going to use our 22.4 because this is at STP. So if we start with what we know, 3.2 times 10 to the 23rd molecules. We know that our next conversion, molecules, has to go on bottom. And from our mole map, we know that we are going to moles. And we know that for every 1 mole, there's 6.02 times 10 to the 23rd molecules. Molecules cancel, now we're in moles. So moles to volume now is our next step, our step going up. So moles go on the bottom, volume, or our liters, go on top, and we know that for every 1 mole, there's 22.4 liters. Our moles cancel, we're left in liters, or our volume, which is what we want, and our answer, if we multiply across the top, divide across the bottom, we get 11.9 liters. Okay, let's try one last one. This one, at STP, what volume does 1.25 grams of helium occupy? Okay, so again, this time we are starting at mass. We are ending at volume. So we have to go mass to moles, moles to volume. Mass to moles uses molar mass, and moles to volume uses our 22.4 because it's in STP. So if we start with what we know, 1.25 grams of He, grams of He. We know that on our next conversion, grams have to go on bottom, moles have to go on top. And our conversion factor from our map tells us it's 1 mole to whatever the molar mass is here. And we get that from the periodic table. So if we go to the periodic table, the big PT, we find out that the molar mass of helium is 4 grams per mole. Remember that molar mass is just the mass of 1 mole of an element or a compound. So 4 grams per 1 mole. Grams, gone. Sorry, He. Now we're in moles of He. Moles are going to have to go on bottom, and on top we are going to liters. We are making that step from moles to liters, going up, and we know that 1 mole is equal to 22.4 liters. Moles are gone, and if we multiply across the top, divide across the bottom, we get 7 liters is the volume that that amount of helium will occupy. Again, if you're having any questions, feel free to come chat with me and we can go over any of this stuff. But we will add that pathway onto our mole maps the next class, and I will see you then. Signing off. Sayonara.